Hello, everyone. My name is Tristan. I work for VMUG, and I just wanted to let you know VMUG, or the VMware User Group, is an independent, global, customer-led organization created to maximize members' use of VMware and partner solutions through knowledge, sharing, training, collaboration, and events. And without further ado, I'll turn it over to Kyle.
Right on. Thank you very much. Appreciate it. Um, I'm going to share my screen here. Hopefully you guys can see that. I'm joined today by my friend and colleague, Joe Hughes. He's going to be manning the Q&A. So if you have good questions, and please ask good questions. On the bottom toolbar, you'll see there's a Q&A button. Please click on that, enter your question, and Joe will get it answered, hopefully live, while we're going through this. So what are we going through today? We're going to talk about VMware in the cloud, specifically Azure and AWS. There's been a lot of noise recently from both of those cloud providers. Pure Storage is grateful to have a partnership with both of them, and we're going to walk through, just some strategies around maximizing performance, maximizing security, and what can we do really in the public cloud. I've been with Pure Storage about 10 and a half years now. I'm a principal technical specialist focused on the cloud. But I come from a world of our on-premises FlashArray and FlashBlade products, which I'm guessing a lot of folks on this call are familiar with. So you might be wondering, well, what is Pure doing in the cloud today? And hopefully you'll get some good answers to those questions and others today. So a brief agenda. We'll just kind of talk about the state of the public cloud in general, with a bit of an emphasis on VMware, some of the challenges and some of the solutions that we see in our existing customers today. And then we'll walk through, some specifics around what is Azure offering from a VMware standpoint, how can Pure help? And then we'll do the same thing at the end with a new service that's in public preview from AWS called Elastic VMware Service. And we'll talk a little bit about some of those offerings there as well. But before we hop into that kind of stuff, we really live in a world where every enterprise has data across public cloud, private cloud, and on premises. I've been in this game long enough to know that silos are a very real thing, and silos are a good way to to waste money and add complexity to your environment. But why are we in this state? It might create more complexity, more silos, in managing your infrastructure. But really, at the end of the day, a hybrid or a multi-cloud environment gives you that needed flexibility, right, to scale, balance, and cost, and optimization, security, and control. And it really it's a requirement to do business today. To operate in a modern enterprise, you need to be able to you need scale, you need agility, you need to be able to innovate and experiment, push the limits. I don't know if anyone's been at a trade show recently, but there's a lot going on with AI. You cannot escape it. So there's just a lot going on in that space. And having this flexibility to do what you need to do where you need to do it is really important. But at the same time, right, we need that rigor, we need that control, to scale and operationalize things that your business come to rely on. But you need security, you need visibility, stability, and control, right? And I think that metric from the study at the bottom, 90% of apps by 2028 will be multi-cloud, really kind of lays the importance around this new hybrid cloud approach. Really, I think that really kind of lays it out there in an easy way to put it. And last thing I would end on, obviously I work for a storage company, so I'm a little biased. Is data is really the lifeblood of your business, right? It's the foundation of your house, and so you need to care for it, right? It needs to be stable, reliable, and it also needs to be secure. With all that being said, though, it needs to be ready and available, whenever and wherever you need it. So that's not only is it the foundation, but it's also the roadway, right? Delivering data to your business where you need it at the right time, is critical to this. As we move forward, though, right, like there are some native challenges, or I shouldn't say native challenges, just some emerging challenges around cloud migrations, right? They can be very costly and very complex. This is a study from McKinsey recently where 75% of organizations report that they're over budget. 38% of them are delayed. Maybe there's that that really mission critical application that you thought would run natively in AWS or Azure and it doesn't. So now you have to refactor it, which delays, your migration. And then, of course, a lot of this leads to the bottom line, right? A lot of wasted spend as customers try to make this move into the cloud. When we look at it through the lens specifically of VMware, right? We working for an enterprise grade storage company know that some of the native offerings in both AWS and Azure, just lack some of those core enterprise features that oftentimes are required in the on-premises world, right? And not being able to scale storage independently of compute, that can lead to wasted spend, like we saw on the previous slide. And those limitations lead to wasted resources, silos, again, things that we've strived to eliminate in the on-premises world, are re-emerging in the cloud in some cases. And of course, as we talked about, as I introduced earlier, right, data protection, data security. Every day we hear about ransomware attacks, similar things like that. So, we need that enterprise level of protection that you see in the on-premises world, but extended to the public cloud. And then last but not least, right, if you're already undergoing a large scale data migration to the public cloud, how much tooling can you keep? How much do you have to throw away? Are you having to learn an entirely new stack in parallel with moving everything to the cloud? So those are really, some of the 4 key reasons that we see VMware migrations either stall or fail entirely. And what that comes down to is, what does IT actually need to successfully get into the public cloud, specifically for VMware? You need storage that can independently scale. You need to be able to know what your budget is going to be and keep it within that budget. I think knowing that what predictable pricing is very important here. You need protection from ransomware attacks. You need the ability to roll forward and roll back your snapshots. Those types of things I think are really important in the cloud. And then, not having to throw away that skill set immediately when you move into Azure or AWS, keeping some of that VMware knowledge as you move things into the cloud, so that people can either be retrained, or you just want to run VMware in the cloud in perpetuity and have a hybrid VMware cloud environment. I think these 4 tenets go a long way in ensuring a successful VMware migration to the cloud. And really what we're going to talk about today is, we'll go over some of the VMware native offerings in AWS and Azure. We'll talk about what Pure Storage is doing in that space. I got a couple of cool demo videos to walk through to show you, how all this stuff works together. So with that, let's first hop into Azure VMware Solution. We at Pure Storage, we're Switzerland, so you can use whatever VMware provider you want. We've got a solution for both covered here. But I figured we've worked with AVS the longest, so we'll start with them. As kind of a brief overview of what this is, right? So essentially, they're running VMware natively on bare metal hardware in Azure within your Azure subscription. And it's very similar to a VMware Cloud Foundation type of deployment. So, you go through a few clicks within the Azure Marketplace, and at the end of it, you've got a 3 or 4 host AVS instance running. What's cool is that it's all connected over the Azure Backbone Network, so you can integrate it with a bunch of native Azure services. And what's really, really important, right, is that you can connect this up to your on-premises VMware estate via something like ExpressRoute or a VPN connection, and leverage that to either do migration, disaster recovery, or maybe you just want a perpetual hybrid cloud environment to be able to move workloads in and out of the public cloud, as necessary. So it's a very slick solution that enables you to really maintain that VMware knowledge and move things back and forth between the two of them. When we look at AVS hosts, so this is actually missing. There's a new AV48 node that was just introduced. It's not very widely available yet. But when we look at the different SKU details for AVS, this is what they give you today. And I want to pay close attention to 2 things in particular here. One of which is that billing down in the bottom right corner of the screen here. What you can do with AVS that I think is probably going to be of interest to a lot of folks is you can either pay as you go. You can pay your monthly or yearly or whatever fee you want, or I should say monthly fee, at current prices. But you can also lock in reserved instances in Azure. Why I mentioned this specifically is that, with a lot of the, let's call it upheaval around some of the recent Broadcom acquisition around licensing costs, this is a really easy way to lock in your licensing costs with VMware for 1, 3, or 5-year term with reserved instances. So again, if you're looking to maybe keep a level amount of spend on your VMware estate, this is a pretty enticing way to do so. The other thing on this slide I wanted to bring up is the amount of vSAN storage that you get. So this is the raw capacity of vSAN storage that you get per node. AVS does this just because they have local NVMe drives. These NVMe drives are fast. I always advocate customers use it. But depending on what FTT level you set it to, FTT equals 1, FTT equals 2, the amount of usable capacity as you start to pool this vSAN storage together in a cluster, might drop by 8 or 9 terabytes per node. So that leads to a relatively small amount of available storage that you have in an AVS cluster relative to the amount of CPU and RAM, right? I mean, the AV64 node, for example, has a terabyte of RAM available and not a lot of storage. So that's really where we come in. The other thing worth noting as well is that we'll talk a little bit about this later, but AV64 nodes can be deployed both in generation 1, which is an express route connection to a private AVS SDDC, or they can be deployed via what they call fleet native, which basically means all the networking for your AVS instance sits directly on top of an Azure virtual network. And we'll show you what that looks like, that later kind of generation 2 model. But as you can see, these AV64 nodes, are huge nodes with a lot of great horsepower, but not a ton of storage. And just to kind of reiterate that point, when we think about this, right, if you have a very large storage footprint on premises that you're looking to migrate into Azure, right? Let's just say, I've got there's 15 nodes here, right? I've got 206 terabytes of storage that I want to migrate over, right? By decoupling storage, and you may be in a scenario, right, where I need that 10 or 11 terabytes of storage, vSAN storage per node, in order to meet that minimum storage threshold, right, in order to move into AVS. So again, decoupling storage here will save a bunch of money and a bunch of wasted memory and compute, right? So really, that's, I think, the core of our value prop. In addition to saving you money in our enterprise feature set, which I'll talk about, is really just enabling you to right size the right amount of compute and the right amount of storage for your unique storage footprint in the cloud. And I mentioned that that enterprise set of data. Those of you who are familiar with the on-premises flash array offering, we do inline deduplication and compression. We do thin provisioning. We have a really cool ransomware remediation tool called Safe Mode. I won't have time to talk about today, but it's a very slick way to protect yourself against ransomware attacks. We have multiple different replication situations. We've got Active Cluster, which enables you to deploy 2 Cloud Block Store appliances within the same region and 2 availability zones and synchronously mirror them. So if you want kind of that 0 RPO, RTO within an Azure region, we've got a solution for that. You can asynchronously move volumes around. We have ActiveDR, which is continuous replication from source to target. Our arrays are made to be highly available, which I'll talk about. And our snapshots, I'll show you a demo of that later. And what's neat is both of these offerings are built natively with Azure managed on top of Azure Managed Disks and AWS Elastic Block Store. And I'll talk about what the architecture looks like. The thing I left out on this slide is always-on encryption. And I wanted to talk about that in detail since, security is in the title of this presentation, so I thought it made sense to mention that. But with Pure, we use AES 256-bit encryption at rest. It's always on by default. You really can't turn it off. And then in terms of how we protect our Pure Cloud Block Store products themselves, we use a Pure Managed encryption key. That encryption key is unique to this Cloud Block Store array that you deploy. And it actually is generated when it's initially deployed and if and when the array boots. Like, for example, you do a controller upgrade and you boot up those new controllers. We use it with the the key itself is within the Purity operating environment level. So it, encrypts that data persisting down to the Azure managed disks or AWS EBS. And it's actually in effect double encrypted because Azure managed disks themselves are encrypted. So quite secure there. We actually store that key within Key Vault or AWS KMS. And then we also support customer managed keys with AWS with plans to bring it to Azure at some point in the future as well. So just from an encryption standpoint, I think we've really taken advantage of the native encryption and tools available inside of both Azure and AWS to extend our encryption methodology to the cloud. And by the way, we are FIPS 140-2 certified, all that good stuff, which enables us to sell into certain 3-letter US government agencies. And now when we think about Cloud Block Store in Azure, the way that we deploy it, right, is this is actually deployed into the customer's subscription. It's deployed into their resource group. They've got an Azure Virtual Network with one or more subnets associated with it for these different services. And then the Cloud Block Store appears in that resource group as a managed application. That managed application, as you can see on the right, is made up of 2 Azure virtual machines. Those Azure virtual machines have numerous Azure managed disks, typically premium SSD v2 attached to them. And then we use storage account to save metadata, Key Vault to save our encryption keys, and then a user managed identity to kind of federate access to this device. The important thing from a security perspective here that I don't think a lot of people know is, when we deploy it into that as a managed application inside of your subscription, you as the customer actually only have read-only permissions to the deployed underlying resources, right? So essentially you can deploy and utilize the managed app, but you cannot get into the managed app and start to, delete stuff. Like, say an employee gets fired or laid off, you probably don't want them to be able to get into this managed app and start to delete individual components. That being said, of course, as the customer, you can delete the entire managed application, which destroys everything. But of course, there are locks and, other things that you can put into place to prevent such an occurrence. So I just wanted to talk briefly about, how this was architected and why. Recent enhancements around Cloud Block Store 2 have actually given you as the customer a lot more control, right? There's things that in the public cloud that you can do that you just cannot do on premises, right? This one you can do on both, but I'll talk about 2 others that are kind of unique to the public cloud that we've introduced recently. First one is that, if there's some new feature or security upgrade that you want to do, you as the customer can now initialize and do your own Purity upgrades. So there's this was for years, a support-driven action. It still can be if you want our support to do it. They'll happily upgrade your array for you. But now via our CLI, you can actually go in and perform Purity upgrades on your own schedule if you want to. The other one, and again, this is unique, right? Because typically in the on-premises world, you have to wait for new shelves or new denser SSDs to arrive. But in the public cloud, it's agile, right? You can just resize an Azure managed disk or add a shelf or things dynamically on the fly because the capacity is just there. But what we do with Cloud Block Store is we actually, by default, and you can change this to the capacity of your choosing, but by default, we deploy CBS at the lowest capacity point. But now customers can, upgrade themselves. So let's just say I want to upgrade this array from 10 terabytes to 20 terabytes. You can do so with no downtime via the CLI. You can also optionally set a threshold where you want the array to upgrade itself. So maybe you don't get that phone call on the weekend. Hey, I'm out of storage. The array will just upgrade itself automatically. It's optional though, of course, because the more data you consume, the more spend you have. So some customers may want to do that, others may not. And then the last one that I think is particularly interesting as well, right? In the on-premises world, we've got the X20, the X50, the X70, all those different SKUs of our product. We have a similar SKU setup in Azure and AWS, where we have a V10 and a V20. So what customers can now do is they can self-upgrade from a V10 to a V20. Again, those Azure VM types are just there. So if as a customer you've kind of overrun your initial V10 deployment from a performance perspective, now you can on demand upgrade yourself to a higher performance SKU 100% online. It's just a controller failover like you would do so in the on-premises world. And when we look at the capabilities of our Cloud Block Store product in Azure, this one uses a premium SSD V2. I actually think we might have bumped up these capacity points recently, but as you can see, you can start very small with a V10 array. Basically assuming 4-to-1 data reduction, you can go a V10 with 9 TIBs, which is quite inexpensive, and you can self-upgrade all the way to a V20 with 500 TIBs effective space or beyond that. So, again, combining that previous slide with this slide, as you can see, you can self-upgrade, self-service, you can deploy as few or as many of these as you want within your subscription as well. So a lot of agility here is available. See some stuff in the chat, by the way. And if you don't mind, please make sure to throw questions in the Q&A box. That would be much appreciated. Just a quick housekeeping item. So we can thank you guys for keeping Joe busy too. Appreciate it. The other thing I wanted to mention, that got messed up. Sorry, so you can't see the title, but it's the name of this product is Pure Storage Cloud for Azure VMware Solution. Sorry about that. I changed the format on the slide and I missed this. But yeah, Pure Storage Cloud is the name of this product. It'll be on a subsequent slide. But what's really exciting about this is our first party managed service within Azure. And as you'll see in the demo, this makes deployment and monitoring and all that good stuff substantially easier than what we've done in the past with Cloud Block Store. Cloud Block Store is still a great product. It's got a more robust feature set as of this recording because it's been around for a while. This is a relatively new product that we're going to be rapidly innovating and bringing more features to. But again, just from an ease of deployment, ease of use, I want to kick the tires on this. I want to connect up storage to AVS quickly and easily. This is a very great solution to run out of the box. And we'll walk through what that looks like in more detail. Starting with this is the Pure Storage Cloud Azure resources that it uses. So we've got a service. That's how you get billed. You get billed directly through Azure, which is pretty nice. You have a storage pool, which is a SAN instance. We then deploy a data store. That data store has some data on it. And then you can also take volume snapshots that you can move around and restore. And with that, let's walk through what the actual deployment of this product looks like. I'm going to start this video and pause it. Just because I want to maximize the screen and make sure it's at high quality. So let me know if I think this is okay. But anyway, here is our Azure subscription. You can see that we've got some subnets. This is a native AVS SDDC. So we can see all of my AVS subnets are running on top of a local AVS VNet. And what I'm going to do here is I'm actually going to create a subnet specifically to be used by Pure Storage Cloud. So I'll give it this starting subnet address range. And the key differentiator here with Pure Storage Cloud, which is new, is that we're actually going to delegate the subnet to a Pure Storage Cloud Block service, right? So this delegated subnet is new with respect to Pure Storage Cloud. So there we can see our subnet is created, and this will come up later in this demo, as you might imagine. So the next thing that we're going to do is actually create effectively our container. your Pure Storage Cloud service. We'll throw that in a resource group. And really, this is setting up your kind of billing interface for this new service. Give it a name. I work at Pure, so this is free, but we'll talk more about how maybe you could try this for free right after this presentation. Again, this is all just basic billing information. Then we create it. This takes about a minute or two to create. And again, this is effectively the container for one or more of your storage pool containers. Okay, so now we're back in our Azure resource group. We can see there is our Pure cloud native service. And now we're going to create an actual service pool. So we'll select that same resource group. We'll give it the storage pool a name. Importantly, the next one, availability zone, you'll want to pay attention to what availability zone AVS is in and select the same one as AVS, Azure VMware Solution. The slider bar for performance, you can start small from a performance perspective and scale it up. So I just cranked it up all the way. However, you can always set it much lower and then scale it up dynamically over time. And then when we click create, it will create this. It does take about an hour to create this because it's building all the backend storage infrastructure. Once it's created though, and I skipped a header, obviously, you just click on connect to Azure VMware Solution. So we're just gonna literally connect up. This is all automated. So this literally just connects up AVS to our Pure Storage Cloud. And that's it. That's all you have to do to deploy this first party managed service, which is why we've gone through the trials and tribulations of building this thing. Is that it's really, really easy for you as the customer to be able to deploy and manage this. Once you get into AVS, so this is an AVS vCenter, you can see the Pure Storage plugin has been installed here, the Pure Storage vSphere plugin. And then if I actually click up at the cluster level, we can right click and then create a data store. We launched this with virtual volumes. We are working on bringing VMFS to this soon as well. So yeah, anyway, that's, and give the data store a name and a size, 30 terabytes, let's say here. And then you're off to the races and have storage provisioned and connected up to this cluster. And so again, I think this is a very easy way to connect Pure with Azure VMware Solution and ideally save yourself some money with enterprise features. Let me move on here. So if I've totally sold you on Pure Storage Cloud, we are in public preview right now. Plans to go GA second half of this year. There is a list of resources attached to this Zoom meeting. This URL is in there. We're getting pretty far along in the preview phase, but we're always looking for customers to kick the tires, give us feedback. You may be able to try this for free. We do have a hosted lab. I don't exactly know what the status of that is today, but if you're interested, please either scan the QR code, visit the URL, and get in touch with us. Because yeah, we've got some, I think, really cool stuff coming down the pipeline here, and really this is just the beginning, right? So that we've talked about Azure quite a bit. Let's shift gears to Elastic VMware Service. Speaking of public preview, that's where this service is right now. It should go GA soon, but this is a new offering. This is not the replacement for VMware Cloud on AWS, but a pretty similar offering to that. And what it is, right, is essentially you've got your AWS VPC. And this enables you to deploy essentially a VMware Cloud Foundation deployment into AWS via the AWS portal or the AWS CLI. So this is actually even more aligned VCF deployment is what they've done here. And what's cool with this is similar to AVS is that you can connect it up to native AWS services as well. Some of the key things with this is it does use Cloud Builder. They're starting off with i4i Metal instances. These are dedicated hosts. They're launching with VCF 5.2.1. Bring your own subscription. They have different consumption models. They do give you full administrative control over this. So after you deploy EVS, you can choose where to send these, but with what I do is within the AWS Secrets Manager, all of your root passwords and administrative passwords are stored there. And again, what's nice is all that tooling, everything you've built in the on-premises world is more or less instantly extensible here. When we think about i4i metal instances, those are some really beefy servers with a terabyte of RAM, 75 gig dual network interfaces, about 100 terabytes of vSAN storage upon deployment in a 4-node cluster. So, and this is not this is usable storage, right? So I don't know what settings you can do with dedupe and compression and all that, but that's kind of what you get with this particular deployment with i4i metal types. When we think about how we integrate this with CBS, and we'll talk a little bit more about what we did for Cloud Block Store specific in AWS in a second, but you basically have a VPC. Inside of that VPC, we again strongly recommend deploying everything into the same availability zone. That really minimizes the amount of network hops between everything. But after that, you can effectively think of the VCF, the management domains deployed, and then I'm attaching Cloud Block Store to it as supplemental storage. Something really important on this slide I like to mention is that not only is iSCSI natively supported, all this stuff works with NVMe TCP as well, right? It just works natively out of the box. I'm actually doing performance testing against this right now. And spoiler alert, it's about 2x to 2.5x times faster than iSCSI. And the setup is a lot easier as well. And you're using a modern fabric. So that's it's pretty good. And the 2 to 2x, 2.5x performance bump really does depend on the block size, the workloads that you're utilizing here. But we're working on a blog and some other kind of outbound material about just how impactful this is. And we will definitely be recommending NVMe TCP as kind of your baseline for this. And with all that being said, too, one of the neat things here is that because you've got full administrative control over EVS, you can deploy the Pure Storage remote plugin. You can deploy VM Analytics. You can really deploy it on both Azure and AWS. But you really get that totally native on-premises like feel with EVS here with our plugin. And just talking briefly about what we built with respect to AWS. Obviously, Azure and AWS are very different clouds. They have different components. And what we've built here is, you can really think of this as the SaaSification of or maybe virtualization of our on-premises flash array. We've got 2 EC2 instances that are running as our stateless controllers. You can either connect to those via iSCSI or NVMe TCP. It's not and/or, it's one or the other, just as a heads up. We use EBS IO2 volumes what we've done is basically built a virtual shelf. A virtual shelf is comprised of 7 virtual drives. So every virtual drive has an IO2 instance, which is effectively our NVRAM. We use Instant Store, and that's basically a read cache. So it's a very fast read cache. The challenge with Instant Store is that it's ephemeral. So if a virtual drive gets rebooted or goes offline for some reason, that data is gone. So we get around that by persisting all data down to durable S3 storage. So if a virtual drive has to go away for some reason, we can rehydrate it from S3 storage up to Instant Store. So that's basically kind of the nuts and bolts here. Oh, and it's auto scaling group. So it's in a separate fault domain. So we've actually built this to kind of enhance the native SLAs on AWS by spreading stuff around within different fault domains. When we think about performance and scale here, we again have a V10 and a V20 array. You can start pretty small and gain capacity quickly. We are working on refreshing the SKU just as a heads up. So expect to see not only more performance, but also more capacity in the fairly near future. But this is what we have today. And again, there's really no limit. That's the nice thing about the cloud, right? You can deploy one or five or 10 of these things if you got the budget for it in the cloud. And speaking of budget, right? I think a unique offering that we do have in AWS is we do have a feature called suspend and resume. This is unique to AWS, at least today. And really what this does is, let's just say you want to use EVS and Cloud Block Store as a disaster recovery site. Just as an example, what you can do is you can activate suspend, and what that does is it terminates the virtual drives, it shuts down your controller, so everything's still there in your VPC, but it's not running, so it's not incurring cost, against your subscription, and all that data is just pushed down to AWS S3. So the only thing you're really paying for when you do suspend is that S3 storage for all of that mission critical data. And then when the time comes, that you want to resume it, it'll rehydrate that data, it'll turn on the controllers, it'll rebuild the virtual drives, and you'll be up and running. So again, just a pretty slick way, I think, of having a kind of a warm DR site in AWS available, should you need it. Last little bit of the presentation here, I wanted to chat about, data mobility specific with VMware. You can use VMFS, vVols, or RDMs. All these things are supported, right? Both on premises as well as within AWS. And in terms of getting that data to AWS, you can use something like Purity Replication, which we touched on earlier, or a native VMware tool like VMware HCX, which I've got a demo on to kind of talk about next. But once you bring that data to AWS on a Cloud Block Store instance, there's a few different ways you can connect it, right? You can get the boot volume and everything running natively in EVS if you want to do that whole hog virtual machine migration. You can use RDMs in EVS, you can use virtual volumes, or you can use ingest iSCSI or ingest NVMe TCP and connect it up to an EC2 instance. So you can kind of think of Cloud Block Store in AWS as that storage workload consolidation tool to kind of get everything connected up, together inside of AWS. I'll kind of show you, again, this is just a super easy, basic example, but I want to show, just kind of what's possible here. There's obviously all this stuff can be scripted, but that's boring to see on a demo video. So I'm going to play just an idea here. So I've got a VM. This, again, I know vVols is going away. I made this before that announcement was made, so please bear with me there. But here's a vVols-based SQL VM. And this is a VM that I want to migrate to EVS. For this, I'm going to use HCX. Again, multiple ways to do this, but I had HCX stood up in the lab and I wanted to check it out. So within HCX, I'm going to find that VM. There it is. I'm going to add it to my list of things to migrate. I see a question on HCX licensing. I believe HCX licensing is included for free with your EVS or AVS subscription. At least it was. So then we're doing cold migration. There's different ways to do it depending on the level of your network connectivity. I'm just going to put in this HCX folder, same format as source. I'm going to use my service mesh as the interconnect. And then here we can see this VM. It's a giant, 10 terabyte or relatively good size VM. There's my EVS network. So I'm going from my source network to my EVS network, which you can specify here, which is one of the really nice selling points of HCX is doing all that kind of automated networking migration for you as part of this. We skipped ahead here a few hours because, this is a relatively large VM, a 10 terabyte VM. But, it took about 2.5, 3 hours, something like that. Here we are in EVS. The VM has been moved. We can see it. There it is, SQL 22 vVols 1. So it's been moved. I'm going to power it on. And again, one of the nice things about vVols, and we're extending this level of functionality elsewhere as well. vVols has a volume group. Inside that volume group, I've got every volume is essentially every data volume is a volume inside of my volume group. So here's a 9 terabyte MySQL data volume. And, this is just kind of the fun stuff you can do so this is running natively in AWS now. I'm going to take this volume, I'm going to create a snapshot of this volume. just again for demonstration purposes, we'll just call this, demo. Okay, so now I've got a volume snapshot of my 9 terabyte volume. I can go back into EVS. This is my test dev instance. Go to our plugin, and I can actually literally import that snapshot that I just took. So again, if you want to move some data around and, I want to have some developers do some test work against that 9 terabyte volume, it just creates, copies that volume snapshot to a new volume and connects it up to my SQL instance. And if we power it on here, I'm skipping ahead a little. This does take a couple minutes, but in the interest of time, I wanted to go through this as quickly as I could. So if we look at a disk manager here, and there we can see there's that 9 terabyte volume. And again, this is just within that VMware ecosystem. I paused here for a second, but it will continue. So now I'm on a AWS EC2 instance. It's a MySQL demo. And it's important to note here, I've already configured this VM for ingest iSCSI and connected it up to CBS here, just to level set. But here I'm actually on my EC2 instance that I'm using. This is that EC2 instance that I've already established iSCSI connectivity with. I'm going to go back to that same VM. Instead of the 9 terabyte volume, I'm going to grab a 1 terabyte database volume here. And you can do all this, everything I just did from the GUI, I can do from within here as well, right? So we'll call this one MySQL demo, MySQL EC2, excuse me. So I've made a snapshot of that volume. I'm going to copy that snapshot to a new volume. Now if we go over and find it. And all this is happening real time, by the way. Our snapshot technology is very fast for those who are familiar with it. So there's my new volume that I just created off of a snapshot, and I've connected it up to this EC2 instance that I'm logged into. So now if I go back over to disk management here, you can see it may have to rescan, but there it is. There's my 1 terabyte volume. Bring it online. And then all my goodies are in there. So again, that's literally how easy it is to kind of use CBS as that Swiss Army knife data consolidation tool and connect it up to not only EVS but also native services, within AWS. Again, this will be in the links, but if you want to learn more about CBS and some of the other fun stuff that we're doing that we didn't have time to chat about today, please click in here. 45 minutes seems like a long time, but it's really not. I always struggle to fit in what we can here. Last slide. If you guys are at VMware Explorer, I will be there. I think Joe will be there. We will be giving some more detailed presentations. We're in booth 513. We usually have some fun swag giveaways and all that good stuff. So would love it if you guys came and saw us. Look at the questions now. Sorry, I did not have a chance to look, and Joe, I don't know if you're on or not, or if there's any that are worth. I think Joe answered all of it. You got them all?
Yeah, it answered all the questions. Really, it was, a couple folks wondering if VCF9 was supported in AVS. Had a couple folks that were just asking questions around replication, but that's about it.
Awesome. Well, thanks for doing that, and thanks for all the questions as well. Let's see. So I see one last question on the source side. What MTU size HCX? So MTU size is really interesting. Azure does not support jumbo frames, so it's just 1500. EVS AWS MTU is set to 8500. So you'll want to account for that in what you do. It's because of their layer 2 networking there. So yeah, that it is with many things. The answer is it depends on what cloud you're using, but EVS native MTU is 8500. AVS is 1500, just as kind of a to baseline level set. And yeah, there's a quick outro. I want to thank you all for joining. And yeah, I will turn it back over. Thanks again for the time.
Awesome. Thank you so much, Kyle. That was awesome. This is just a reminder to everyone that this session was recorded. The recording will be distributed in a wrap-up email soon after the webcast. Upon exiting the webcast, you guys will be prompted to fill out a survey. Please fill this out. This helps us provide fresh, relevant content in future webcasts, and then use code community for a 10% off a 1-year VMUG Advantage membership. So thank you all, and hope to see you again soon.
Have a nice day.